Okay with it. Good evening. Can you hear me? Yeah. Yeah. Okay, we can start the class. Today is not our regular day because yesterday I couldn't able to do the class. Therefore, today is an extra day. Therefore, this lesson will be recorded and said that to the other students also because most of the students cannot pass it today. But I will send the recording immediate after the lesson. uh, then they can watch the recording before the next class. So, as we discussed earlier, our regular paper class will be scheduled on Wednesday from 7:30 to 10:30. Okay. Okay. We can start the class with it. As we discussed earlier, today I'm going to discuss about circular motion EQR. That means exam questions reviewing part. So previously you were given that paper. So today I'm going to discuss that paper. Okay, that means past paper questions based on circular motion. Okay, shall we start? මට සමහරකට කියලා තිබ්බා බලමු. Okay, I will send the paper again today. So if we don't have that paper, now you can refer that paper. Okay. Okay. I have sent that paper to the group, so you can refer that paper today. Okay, we can start the discussion. Okay, first one. A particle moving in a circle of radius 2 meters at a constant speed has a period of rotation 2 seconds. Okay. Its acceleration towards the center of the circle is. Okay. So you are given the radius and the period. You are given the radius and the period, and you are asked the acceleration towards the center. That means centripetal acceleration. You know centripetal acceleration is omega squared. Therefore, instead of omega squared, I can write 2 pi over t squared. Therefore, 2 pi squared means 4 pi squared over t squared. Put it. No need to write this equation. But I have written this equation to clarify the paper question put it. But when you are doing the question, no need to write this equation. Just apply the values. Remember in this equation. And just apply the values put. And okay, then acceleration. Here, radius is 2 meter. 4 pi square. T is 2, no? T is 2. Yes, T is 2 means this one is 4. And 4 to 4 will be cancelled out. The answer is answer number 4. Therefore, correct answer is answer number 4. Then, second part. Two particles A and B are moving in concentric circles, RA and RB. such that their periods of rotations are same. The ratio between centripetal acceleration A and centripetal acceleration divided by centripetal acceleration B. What is the answer? What is the answer? Answer the second one. Now period is constant. Period is constant. You know, period. Period means capital T ni putih. If period is a constant, definitely omega should be a constant. Omega should be a constant. Therefore, here omega is a constant. Then you know A is equal R omega square. A is equal R omega square. Therefore, if omega is a constant, definitely acceleration is directly proportional to the radius, because omega squared is a constant. Because now you know you are given period is a constant. As period is a constant, definitely omega is a constant today. Therefore, no need to worry about this omega. Don't try this one. Therefore, acceleration, centripetal acceleration is directly proportional to the radius. Therefore, the ratio between centripetal acceleration should be equal to the ratio between radius. Radius. Centripetal acceleration is directly proportional to the radius. Therefore, ratio between centripetal acceleration should be equal to the ratio between two radius. Therefore, answer number one, because A is directly proportional to radius. A is directly proportional to radius as omega is a constant. That is the argument. As omega is a constant, A is directly proportional to radius. Then, third one. A small mass is kept on a horizontal circular table which can rotate about a vertical axis passing through a center of a table. The mass starts to slip when the angular velocity of the table becomes omega. If the distance to the mass from the center of the table is double, the minimum angular velocity required for mass to start slipping is. Well, okay. So you know, now there is a mass with it. Now this is a circle. Okay. Actually, no need to write anything. To get the answer. So you know, but I have to explain the answer with it. First, I will do this one in a shorter way. Then I will explain to you. So you know, now there is an object here on a disk. Now this is a disk. On this disk, there is an object here. Now the entire system rotates about this axis. Now, according to the question, this ball starts to slip when the angular speed is equal to omega. And you are asked, if the distance is doubled from the center, then what will be the angular speed at which this object is start to slip. දැන් අපි බලමු මොකක්ද වෙන්නේ කියලා. So you know, definitely you know, during this circular motion, what would be the centripetal force? What would be the centripetal force? Tell me that thing. During this circular motion, what would be the centripetal force exerted on this small object? Small object එකේ centripetal force එක වෙන්නේ මොකක්ද මෙතන? ටක් ගාලා කියන්න. Small object එකේ centripetal force එක වෙන්නේ මොකක්ද? That's it. Read it. What is the centripetal force here? Definitely, what will happen when this rotates? What will happen? This object tries to move away from the center. Therefore, definitely, if you do this experiment, then you can observe that experiment. Experience. You can experience the thing. Therefore, this object tries to move away from the center. Therefore, definitely there will be a friction force towards the opposite direction of that attempted motion. Therefore, definitely there is a friction force towards the center of the circle. By this friction force, actually this friction force provides the required centripetal force to rotate this object. Actually, this friction force is the force that provides the centripetal force. Is that clear? If it is clear, please raise the hand. Turn on the sun. Thank you. Okay. Now you are asked about this question. This question is about when this object tries to slip away. That means now there's a limiting condition. There's a limiting condition because this friction force has come to the maximum level and now he cannot bear this object. Now this object tries to move away. It starts slipping. That means this friction force come to its limiting condition. Therefore, this friction force should be equal to its limiting value. That means mu r. Therefore, this friction force should be equal to mu r. Means this is this. Means this perpendicular reaction should be equal to A because there is no motion in vertical direction. Right. Therefore, friction force is equal mu r, mu mg. So that is the centripetal force. Therefore, if you apply F equal ma towards the center, centripetal force is equal to mu r. Mu r means mu mg. Don't write any more steps with it. Mu mg. That is the centripetal force is equal m r omega square. Is that clear? If it is clear, please raise the hand. Therefore, M12 will be cancelled out today. M12 will be cancelled out. Then definitely, now R is double. R is double, that is the only thing. Therefore, mu g is a constant. Mu means that is the coefficient of friction, that is a constant. That is a constant for this table. Therefore, this is a constant, g is a constant. Therefore, omega depends on 1 over root r. Depends on 1 over root r. May I repeat again? Omega depends on 1 over root r. Therefore, omega 2 over omega 1 should be equal. බලන්න මෙයා ඉන්නේ යට. එතකොට මෙයාට අදාළ එකයි ඉන්නේ යට. මෙයාට අදාළ එකයි ඉන්නේ උඩ. හරි. මෙයාට අදාළ එකයි ඉන්නේ යට. නිසා මෙයාට අදාළ එක ඉන්නේ යට. ඉතින් ගත්තොත් මෙතන ඉන්නේ 2 නේ. 2 times r. 2 times r. Here r. Yeah. So you know omega is equal, omega 1 is equal omega. Omega 1 is given as omega. Therefore, omega 2 should be equal, r term will be cancelled out, okay? Equal omega over root 2. Omega over root 2. Is that clear? If it is clear, please raise the hand. Actually, if you can understand this question, no need to write anything or no need to draw anything. You can start from here. You can start from here. මතක තියාගන්න question එකක් දුන්නට පස්සේ ටක් ගාලා ඔළුව එන ගන්න පුළුවන් නම් ටක් ගාලා ආන්සර් ෆිගර් එකක් අදින්න ඕනේ. හරි. මම අපි මේ කතා කරන්නේ MCQ පුතේ. MCQ කියලා කියන්නේ පුළුවන් තරම් අපි ටයිම් එක සේව් කරගන්න ඕනේ. හරි. Okay. Then the next question. ඒක අපි දන්නවනේ. What is the answer for next question? We have done that thing in our previous class. The horizontal table is rotating in a uniform angular velocity about a vertical axis passing through its center. A mass, simple M, is at rest on the table without slipping. Observer A is sitting on the table while the observer B is standing on the table. While standing on the floor, on the floor, as shown in the figure. And the total horizontal force on simple M. Now you are asked to mark the forces with respect to observers. As I mentioned you earlier, this is regarding reference frame. This is regarding reference frame. Therefore, reference frame to reference frame, the experienced forces, that means the force experienced by the observer may vary. Therefore, reference frame to reference frame, then that will be vary. We have done that thing. So now there is an observer here. He is observer A. There's a mass here, M. Here there's observer B. So you know, with respect to observer A, this object should be in stationary condition. Okay. Suppose observer A cannot see any rotation. It can observer A ට වටේ පිටේ rotate වෙන පේන්නේ නැහැ කියලා හිතන්න. පේන්නේ නැහැ කියලා හිතලා ඔය මේක rotate වෙනවා කියලා හිතන්න. මේක හරියට නිකන් අපි earth එකේ ඉන්නවා වගේ. අපි earth එකේ උඩ ඉන්නකොට අපි දන්නවා මේ earth එක කරගෙනවා කියලා. හැබැයි මට පේනවනේ මාත් එක්ක මේ ඉන්න අනිත් එක්කන කරගෙනවා කියලා අපට පේනවා. දැන් මේ පෑන ගන්න. Now actually this pen rotates with the earth. No, not with actually not only pain but also all bodies. All the bodies are rotating with the earth, but we cannot see it. We cannot see that because all of us are in the same reference frame. Same reference frame. අපි අට්ටියම ඉන්නේ එකම frame එකේ. ඒක නිසා අපිට පේන්නේ අපි කට්ටිය rotated. හරිද? ඒක වගේ තමයි ඉතින්. So A and M both are in the same reference frame. Therefore, relative to A, there is no motion of M. Therefore, there is no resultant force. There is no resultant force exerted on simple N with respect to A. Okay, with respect to A, definitely there is no force exerted on it because it is in stationary condition with respect to A because both are in the same plane. But with respect to B, M and A both are rotating in a circular path. If they are rotating in a circular path, definitely there should be a centripetal acceleration, centripetal force. Definitely with respect to B, definitely there should be a force exerted to the center. Otherwise, it cannot rotate. It cannot rotate in a circular path. Therefore, with respect to B, there should be a force toward the center. With respect to A, there should not be any forces. Is that clear? Therefore, what is the answer? Answer is answer number 1. No? According to A, resultant force is 0. According to B, towards the center, definitely should be answer number 1. Is that clear? If it is clear, please raise the hand. Thank you. Okay. ඊළඟට පොඩ්ඩක් මතක තියාගන්න ඕනේ අපි next paper class එකේ ඉඳලා ඊළඟ paper class එකේ අපි class එකේදී test එකක් දෙනවා. class එකේදී test එකක් දෙනවා. ඒ test එක දෙන නිසා අපි කරනවා. ලොකු test එකක් නෙවෙයි. It's about 10 questions. මොකද අපි class එකට ඕගොල්ලන්ට දීලා ඊට පස්සේ discuss කරන්න time එකක් තියෙනත් එක ඒ නිසා questions 10ක් දෙනවා. questions 10 set වෙලා ඉන්න. එතකොට අපිට ඒවලේ කතා කරලා ඒවලේ දීලා question එක ඒවලේ discuss කරන්න පුළුවන්. time කරලා දෙන්නේ. ඕගොල්ලෝ අනිවාර්යෙන් time කරලා ලියන්න ඕනේ. time කරලා දෙන්නේ නිසා ඒකට පොඩ්ඩක් set වෙලා ඉන්න. හරි. paper class එක තාම මේ පටන් ගත ගමන් ඒ නිසා ලොකුවට මම මෙව කරන්නේ. මේ අර ඉන්ෆ්ලුවන්ස් කරන්නේ නැහැ ළමයිට මොකද පාඩම් කරන්න time එකක් තියෙන නිසා. හැබැයි මේ අතරේ පොඩ්ඩක් පාඩම් කරලා තියාගන්න දැන් ඕගොල්ලන්ට වැකේෂන් එකේ ආවා කියන්න බැරුණා. ලබන සතියේ මුතේ වැකේෂන් එක මොකද්ද අපිට එතකොට බදාදා මේ අඟහරුවාද next Tuesday full day class එකක්. next Tuesday class එක full day class එකක්. waves class එක next Tuesday full day class එකක්. We will start that class here 7 o'clock. 7 o'clock we will start the class. Then it will be continued until 10 o'clock at night. Okay. It will be a full day class. It's about waves. Okay. waves කතා කරන්නේ waves වල මම note එක මම ඔයගලන්ට එවනවා කියලා කිව්වා. note එක post කරගන්න නම් බැරි වෙයි දාට කලින්. මොකද ඇත්තටම මේ මට ඒක මේ full day class එකක් කියලා ඇත්තටම මට ඒක අමතකුණා. මේ දවස්වලදී ඇත්තටම ලොකු busy schedule එකක් ඇත්තටම තියෙනවා මගේ. මොකක්ද ඒකත් එක්ක මම නෝට් එක මම ඕගොල්ලන්ට ඒ අතරතුර soft copies ටික එවන්නම් පුතේ hard copies ටික මම next week within next week post කරන්නම් අලුතෙන් ආපු ළමයි මට පොඩ්ඩක් මේ addresses ටික දෙන්න post කරන්න මොනවද ඒක ඇතුලේ එතකොට අපිට waves ටිකේ ලොකු ප්‍රමාණයක් cover කරගන්න පුළුවන් වෙයි Tuesday class එකේ. හරි. ඒ නිසා Tuesday class එක next Tuesday class එක full day class එකක්. full day class එකක්. ඒ full day class එක waves lesson එකේ මම content එක කියන්නම්. මොකද full day class එක නිසා මම බැලුවේ අපිට උදේ වරුවේ waves පාඩම සහ ඊට පස්සේ හවස් වරුවේ අපිට කතා කරන්න පුළුවන් live පාඩම පටන් ගන්න පුළුවන්. මොකද ඒක ඔයගොල්ලන්ට ඊළඟ ටර්ම් එකට වුණා ඒ කියන්නේ අනිවාර්යෙන් අවශ්‍ය වෙන නිසා ලයිට් ලෙසන් එක පටන් ගන්න පුළුවන්. එහෙමොත් මේ උදේ ටයිම් එක වේව් ලෙසන් එකට සහ ඉවිනින් ටයිම් එක ලයිට් ලෙසන් එකට අපි allocate කරනවා. අපි එහෙම බලමු. හරි. මොකක්ද? දැන් ඊට කලින් කොහමද අපි හම්බ වෙනන්නේ පුතේ මේ සන්ඩේ හම්බ වෙන නිසා අපිට කතා කරන්න පුළුවන්. ඒ නිසා ඒකත් බලමු. ඊට පස්සේ Wednesday අපිට night time තමයි කරන්නේ. මොකද මට 25 කට්ටිය ඉන්නවා. ඒක. Wednesday night time තමයි කරන්නේ. එතකොට එක දවසක් ඕගොල්ලන්ගේ full day class එකක් කරන්න පුළුවන්. හරි. Okay. නැත්නම් ඔයගොල්ලන්ට next Wednesday රෑ බැරි නම් කියන්නේ මට Thursday morning හරි කමන්න කරන්න පුළුවන්. Thursday morning. මායක පොඩ්ඩක් අහන්න. මම poll එකක් දාලා අහන්න. මොකද Wednesday බැරි කට්ටිය ළමයි ඉන්න නිසා. Okay. That is our next week class plan. Okay, next week class plan. So there will be a full day class on next Tuesday. That is based on waves lesson. Mostly we will do two sessions. First session will be allocated for waves, and the evening session will be allocated for the light lesson. Okay, then question number 5. What is the answer for question number 5? An object moves along a horizontal circular path on an inner surface of a smooth conical shaped vessel, as shown in the figure. The force or forces acting on the object as observed by a stationary observer is. What are the forces acting on it? Question number 5. What is the answer? Question number 5. We are discussing circular motion questions. Circular motion CQR. So this is 2001 question. 2001 question. Previously we have discussed 1998, 1999. There are two questions in 1999 and 2000. Now this question is 2001 question. Now here there is a conical shaped vessel. And here there is an object. Moving in a horizontal path in this vessel. And you are asked to mark the forces acting on him. So what are the forces? Tell me, what are the forces acting on this man? Forces means forces, Mute, not resolve component. You do not want to resolve the forces. You ask the forces. What are the forces acting on this man? What are the forces, Mute? Shashwini? What are the forces? Yes, first one is normal reaction. That is obvious because there is a touch. There is a connection between the vessel and the man. Definitely there should be a contact reaction because there's a contact. Definitely there's a contact reaction. Yes. Normal reaction is there. The other one is there's a reaction force. There's a reaction force on this man. Other, yes, the weight. The weight. Other one is the weight. So those are the two forces acting on this man. Those are the two forces acting on this man. Okay. Therefore, there is no evidence regarding a friction force, and that is not in your answers. Therefore, do not worry about the friction force because it is not in our answers. Okay. And so there are only two forces. One is weight, other one is the reaction force between the vessel and the man. Therefore, answer is answer number 2. Weight of the object and reaction force normal to the surface only. That is the answer. Okay. Then, question number 6. A child of mass 20 kilogram is sitting on a swing of negligible mass. The swing is attached to its pivot by 2 ropes, each of 3 meter length. The maximum speed of child during swing is found to be 3 ms minus 1. The maximum tension in each rope is the maximum tension in each rope is the maximum tension. So you know when there's a swing putty, definitely the maximum tension force is occurred at the bottom. At the bottom. Okay. As we described in vertical circular motion, the maximum tension force is occurred at the bottom and the longest tension force is occurred at the topmost position. Therefore, the maximum tension force should be occurred at the bottom. Therefore, you have to apply F equal ma when the object is at bottom. Now, this swing has 2 ropes. 2 ropes. Therefore, in upward direction, there should be 2 tension force. In downward direction, there is only a weight. There's only a weight. That is 200. Therefore, in upward direction, there should be 2 times tension force. Downward direction, there should be only a weight. බලන්න එකපාර ලියන්න මේක හිත ඉන්න බෑ. එකපාර ලියන්න මම කියන දේ තේරුම් ගන්න. දැන් මම බලන්න හිතෙන් ඔයා මේක මම කියන දේ හිතෙන් මම ගන්න ඕන ඔළුවට. බලන්න. Now there's a swing. Now the swing, now the swing is at the bottommost position. So if it is at bottommost position, there are 2 tension force exerted towards the upward direction. The weight is in downward direction. So if we apply F equal ma towards the center, 2 times T minus 200 is the force. 2T is in the upward direction. Downward direction, there is a weight to take, that is 200. Is equal, okay. mv squared over r. mv squared over r. m is 280. m is 280. v squared means now the maximum velocity is 3. Therefore, 3 squared. v squared means 3 squared over r also equal to 3. Therefore, 3 to 3 will be cancelled out. Okay, this is 60. Therefore, 60 means 2t is equal 260. That means t means 130. 130. එච්චරයි. ආයි මේකේ ෆිගර් එකක් හැඳලා මේක ලස්සනට අර මේ ටෙන්ෂන් ෆෝසස් ලකුණු කරලා එහෙම කර කර ඉන්න ගියොත් පුතේ විනාඩි දෙකකින් මේක හදන්න බෑ. විනාඩි දෙකකින් මේක හදන්න බෑ. මම මේකයි මේ පුළුවන් තරම් හිතෙන් කතා කරන්නේ. හරිද? දැන් මේ ෆිගර්ස් කලින් මම ඇන්දේ අර එක්ස්ප්ලেইন කරන්න ඕන නිසා. එහෙම නැතුවත් එන්න ඔයගොල්ලන්ට දුක තේරෙන්න තියෙනවානේ. ඒක නිසා හැබැයි මේක දැන් මම කිව්වා මට ඕන නම් ආයෙසරක් මම කියන්න පුළුවන්. ඔයගොල්ලන්ට ඕන නම්. හරි. හැබැයි මම හැම වෙලෙම කියන්නේ එහෙම ස්ටෙප්ස් වලට හුරු වෙන්න එපා. මෙහෙම ස්ටෙප්ස් වලට හුරු වෙන්න එපා. පුළුවන් තරම් ස්ටෙප්ස් ගන්න අඩු කරන්න. එහෙම නැත්නම් within 2 minutes ඔයාලට හදන්න බෑ. මතක තියාගන්න මම හැමෝටම මේ කියන්නේ. පුතේ ඔයාලා හොඳට තියදී දන්නවා නම් ඔය MCQ පේපර් එක ගෙදර ගිහිල්ලා ඔයාලා කරපන් කියලා කිව්වොත් කරන්න පුළුවන්. ඔයාලා ෆිසික්ස් දන්නේ නැත්නම් ඔයාලා ෆිසික්ස් දන්නවා. ඔයාලා ෆිසික්ස් තියදී දන්නවා නම් අහිංසර කරන්න පුළුවන්. ප්‍රශ්න මොකක්ද? වෙලාවට කරන්න. ඒ වෙලාව මීට වෙන්නේ නැහැ. ටික වෙලා ගියාට පස්සේ මේක මෙහෙම වෙනවා ක්ලික් කරනවා. ඒක නිසා මතක තියාගන්න ගොඩක් ළමයි තියෙන ප්‍රශ්න ඕක. ඒක නිසා within the given time if you want to complete the paper within the given time you have to practice this one. Actually I have told this in every question paper in every tube. Okay. What is the reason to repeat this? Repeat this up. I must make I can. What is the reason? Practice. You have to practice this one. That is the only option. That is the only option. I with an options they don't have to become option. They go out MCQ equaling or MCQ equaling or no, hitting on practice. දැන් උගලන්ට ප්‍රැක්ටිස් වෙන්න පුළුවන් ඕන තරම් කල් තියෙනවා. දැන් ඒකයි මම ප්‍රැක්ටිස් කරවන්න ඕගොල්ලන්ට. ඕගොල්ලන්ට ප්‍රැක්ටිස් කරවන්න. හරි. ඒක නිසා මට මෙතන තියෙන එකම ප්‍රශ්නාවය තමයි මට ඔයාලා කරන දේ පේන්නේ නැහැ. හරි. කරන දේ පේන්නේ නැහැ. ඒ නිසා ඔයාලට හවස් වෙලා අනිවාර්යෙන් මේ වැඩි ප්‍රැක්ටිස් වෙන්න. මේ වැඩි ප්‍රැක්ටිස් වෙන්න දුවපොතේ. හරි අමාරුයි. අපි ඔයාලා ටික වෙලාවකදී මේක ප්‍රැක්ටිස් වෙද්දී ඔයාලට තේරෙනවා. ඔයාලට මිස්ටේක් වෙනවා අඩු. ටික වෙලාවක් යද්දී මුලින් මිස්ටේක් වෙයි. මුලින් මිස්ටේක් වෙයි. මේක හිතන්න බෑ. මේක ෆිගර් එක අදින්න ඕනේ මේක හිතන්න. එහෙම හිතෙන්න පුළුවන්. හරි. හැබැයි ඔයාලා චුට්ට ප්‍රැක්ටිස් වෙන්න ගත්තට පස්සේ ඔයාලා ඉබේ පුරුදු වෙනවා. හරියට ප්‍රැක්ටිස් කරොත් ඒ හරියට ප්‍රැක්ටිස් කරන එක්කෙනා කවදාවත් කැමති නෑ අදින්න. දැන් මම මේක පැහැදිලි කරගෙන යන්නේ මම ජීවිතේට මම හදන එක ගානකවත් අනිවාර්යෙන්ම මේක නෝලුකට යන්නේ නැත්නම් අඳුත් නිසා සාමාන්‍යයෙන් පුතේ ෆිගර් එකක් අඳිනවා අඩු. ෆිගර් එකක් අඳිනවා අඩු ටක් ගාලා හිතෙන්ම තමයි ගන්න try කරන්නේ. ඔච්චර කිව්වම ඒක අර පුරුණාට පස්සේ ඒකම කියන්නේ ඒක පුරුණාට පස්සේ ඔයාලා ඔටෝමැටිකලි යනවා. හරිද? මේක පොඩ්ඩක් බලන්න. පොඩ්ඩක් ප්‍රැක්ටිස් කරන්න. Okay. The next question. Seventh one. A toy car connected into a fixed point by an elastic string as shown in the figure travels in a horizontal circle of a radius 2r. The initial unstretched length of the elastic string is r. Now this toy car rotates in a circular path of 2r. But the initial unstretched length of the string is r. That means now this string is stretched up to another simple r. You have to understand that thing. The period of rotation of this car is capital T. the car is then speed up until it is moving in a circle of radius 3r. Now the speed is increased. As the speed is increased, now the radius also increases. If the string obeys Hooke's law means F equal kx, and resistive forces are negligible, the new period of rotation of the car will be high. Now, this is the unstretched string. Unstretched string. It is the length is L. Then, during the first rotation, this string is stretched up to 2L. 2L. Then the speed is increased, so the string is stretched up to 3L. Up to 3L. So as this string is stretched, now there's a tension force. So this tension force is equal to the force exerted on this string due to the stretch. And therefore, due to the stretch, the force, the excess force should be equal F equal kx. This is called Hooke's law. And therefore, initial tension force. Time is given as t. Time is given. Therefore, you know, now k is a constant because k is the spring constant. Okay, or force constant. Therefore, that is a constant for this material. So this force, the force should be equal to the x. X means elongation. Therefore, initial tension force should be corresponding to the initial elongation, that is L. Because initial length is L, now elongation also L. Then final tension force F2 is equal to the, or is proportional to the final elongation. Final elongation means, now this is the initial length, elongation should be 2L, because here to here 3L. Therefore, initial elongation should be 3L. Now you have to combine this. So this is the centripetal force. This force is equal to centripetal force. This tension force is the centripetal force of this circular motion. So centripetal force is equal m r omega square. And so you know the centripetal force. The centripetal force is equal r omega square. So instead of writing omega squared, I can write 4 phi squared over t, because omega is equal 2 phi over t. Therefore, centripetal force is equal r 4 phi squared over t squared. 4 phi squared is a constant. 4 phi squared is a constant. Therefore, centripetal force is directly proportional to r over t squared. R of t square. R of t square. And therefore, this is the centripetal force. Now, centripetal force is directly proportional to R over T squared put and that one also proportional to the elongation. That one also proportional to the elongation. Elongation. Okay, elongation is proportionality. Therefore, I can write R1 over T1 is square should be equal initial elongation divided by final elongation. Sorry, T1 is square negative. R2 over T2 square. Is that clear? I will explain it again. R over T square. R over T square is directly proportional to X. Directly proportional to X. Therefore, initial radius is 2L. Initial radius is 2L. Initial period is given capital T square. This is the initial one. Okay. Divided by the final one. The final one is radius is now 3R. So 3L. Therefore, 3L over now T2 square. This should be equal to the ratio between elongation. So here elongation put a L. Here elongation is L. Here elongation is 2A. L will be cancelled out. That is half. Then make it a capital one. Therefore, if you multiply this one by 2, 4 divided by T squared should be equal 3 divided by T2 squared. එහෙනම් මේක අරගෙන යන්න මේක අරගෙන එන්න. එහෙනම් T2 should be equal root 3 root 3. T2 is equal root 3 over 2 times capital T. Root 3 over 2 times capital T. Is that clear? If it is clear, please trace that. මේක තේරෙනවද පුස්සා? හරි අනිත් පැත්තේ තේරුණාද මම ආශා කියන්නේ? Okay, I will explain it again. බලන්න හැමෝම. බලන්න ඇස. Look at this one. Now there is a string. This is elastic string. That means it can be stretched. Now we have attached a ball to this string and rotate about this circular path. As this object rotates about this circular path, this string stretches another simple L distance. Therefore, the total distance, the total length of this string, now it is equal to A. Therefore, this object rotates in a 2L in a circle which is whose radius is equal to 2L. My object again and radius is 2L circle. Then මොකද කරන්නේ? Now the speed of rotation is increased. දැන් මේ speed of rotation එක increase කරනවා. හරිද? දැන් මොකද වෙන්නේ? ඒක increase කරන නිසා මෙයාගේ again now the length of the string is increased. මේ string එකේ length එක increase වෙලා තියෙන්නේ. Increased by another L. Now the stretch length is 2L. This length is L. Initial length is L. Elongation is 2L. දැන් අපිට ගන්න තියෙන්නේ මෙයාගේ equation දාන එක. මෙයාගේ equations දාන එක දැන්. දැන් මෙතන tension එකක් ඇති වෙනවා තියෙන්නේ. මේ tension එක ඇති වෙන්නේ මේ stretch එක නිසා. මේ tension එක ඇති වෙන්නේ පුතේ මේ stretch එක නිසා. stretch එක නිසා ඇති වෙන force එක මාක් කරලා අපි හදුනාට පස්සේ ඇතිවෙන force එක කොහොමද හොයන්නේ? Hooke's law එකෙන්. Hooke's law. F equal kx. K කියලා කියන්නේ යාගේ spring constant එක. එහෙම නැත්නම් අපි කියනවා force constant එක කියලා. හරි? ඒක කොහොමද constant එක ගන්නකො? Therefore, as this is a constant, F directly proportional to the elongation. F directly proportional to the elongation. So initial elongation is L. Therefore, initial force is equal to L. L is corresponding to L. The final elongation is 2L. Therefore, final force. Sorry, 3L, 2L only. Sorry. 2L. Elongation is 2L. Abhi use karena form. You have to apply F equal ma to this direction. Now force is F, and if you apply F equal ma into this direction, now this is centripetal force. Centripetal force is equal to R omega square. Therefore, instead of writing omega squared, I can write 2 phi over T is square of 2 pi over C. Is square of 2 phi over 3. Sorry, is square of 2 phi over T. 3 phi over T. And if you take, because omega is equal to 5 over T, you have to take the square of omega. Therefore, 2 phi over T square is equal 4 phi squared over T square. 4 pi squared over T square. From here, you know this one is a constant. Therefore, no need to write that one. Therefore, centripetal force is directly proportional to R over T square. That is the centripetal force. Centripetal force is directly proportional to R over T square. From here, the centripetal force is directly proportional to X. From here, centripetal force is equal directly proportional to R over T square. From here, centripetal force is directly proportional to X. Therefore, centripetal force directly proportional to R over T squared, and that is directly proportional to X. So that means R over T squared is directly proportional to X. And R over T squared directly proportional to elongation. Therefore, අපි අවස්ථා දෙකකදී R over T squared කියන ratio එක ගත්තොත් අවස්ථා දෙකකදී R over T squared කියන ratio එක ගත්තොත් ඒක equal වෙන්න ඕනි ඒ අවස්ථා දෙකට අනුරූප elongations දෙකේ ratio එක. Therefore, if you take the ratio between R over T squared in 2 times, it should be equal to the ratio between elongation, corresponding elongations. Therefore, initial R over T squared is equal. Initial R means 2L. Initial R is 2L. Initial T means that is given T. Final R is equal 3L. Final period, that is actually final period that should be determined today, is T2 square. So this ratio should be equal to the elongation, ratio between elongation. Initial elongation is equal L, final elongation is equal to L put A. 2A. If I simplify everything, L12 will be cancelled out, L12 will be cancelled out. Therefore, you can take 2 here, therefore 4 over T square, and you can bring this part to here, 3 over T2 square. Then you have to cross product this thing and take this square. Take this square. Make a square root take up to square root 3 over 2 is equal, sorry, into T is equal to T2. There question, if you got that, please raise there. Take the question. Question. I need responses from everyone. There cannot clear. If you got that one, please raise the hand. Okay. Then everyone. Now we have done 7 questions. Now everyone please do question number 8, 9, 10. 8, 9, 10 are some easy questions. Then please do the question number 11, 12. 11, 12. 11, 12, 14 and 17. 11, 12, 14 and 17. Please do the question 11, 12, 14 and 17 quickly. 11, 12, 14 and 17. 11, 12, 14 and 17. Please do them quickly. Okay. Have you done? Have you done? Question number 11, 12. Okay, question number 11. Follow. Follow with the question number 11. The particle is moving in a circular orbit of radius 10 meter at one instant. The speed of particle is 10 ms minus 1 and is increasing at a rate of 10 ms minus 2. That means it's acceleration. Acceleration means translational and tangential acceleration with it, because it is given the velocity and the rate of change of the velocity. That means velocity is into the tangential direction. Therefore, now it is given the tangential acceleration part. The angle between the velocity vector and the resultant acceleration vector of the particle at that instant is. It is somewhat different question, but a different question. Therefore, that is the reason I have chosen that question. Okay, now we can look into the question. Question number 11. Now, this is the tangential velocity. The velocity is 10 ms minus 1 according to the data out there, and it says the velocity increasing at a rate of 10 ms minus 2. That means it is given the tangential component of the acceleration. Tangential component of the acceleration is 10 ms minus 1, ms minus 2. And you are asked to determine the angle between the resultant acceleration and the velocity. So velocity is known. It is known that is 10 ms minus 1. Therefore, you have to find the resultant acceleration. So as you know, the resultant acceleration means the resultant of tangential part and the radial part. Tangential part and the radial part. Therefore, you have to find the radial acceleration. Radial acceleration means centripetal acceleration to determine this thing. Okay. Here, this length is 10 meter. Therefore, radial acceleration part. Yeah, should be equal to v squared over r. V squared means 10 squared. V is 10 squared over r means 10 meter. 10 to 10 will be cancelled out. Therefore, radial component also equal to 10. Radial component also equal to 10. Therefore, there are two acceleration components. One is 10 ms minus 2 to this direction. Other one is 10 ms minus 2 to this direction. Here, radial component. Here, tangential component. And you know, the velocity also in this direction, that is 10 ms minus 1. This is velocity. So you know this one was this one is 10. Therefore, definitely the result, this is the resultant. This is the resultant acceleration. Definitely the angle between the resultant acceleration and one of these components should be 45, because this both are equal in magnitude. Both are equal in magnitude and perpendicular to each other. Therefore, this angle or this angle should be 45 degree. 45 degree. Therefore, the angle between the resultant acceleration and the velocity should be 45 degree. 45 degree. Is that clear? If it is clear, please raise the hand to start. Perhaps little. Okay. Then, therefore, answer is 45 degree. 45 degree. Now, question number 12. Question number 12. That is very interesting question. Question number 12. Question number 12. You can take a screenshot or you can note down this thing. Question number 12. One. Question number 12. Now, question number 12 means 2008 question. Figure shows a space colony of radius 10 to the power 3 meter rotating about its axis. At what angular speed must the space colony be rotated so that an astronaut standing on the floor of the colony experiences a push on his feet that equals weight on the earth? Now there's a space colony. This is a space colony. Okay. This one is a space colony. Now, according to the figure, this is the earth. You know. Now there's a man standing on the space colony. Now tell me, what are the forces exerted on this man? What are the forces exerted on this man? Now this is space colony පුතේ මේක space colony එකේ තියෙන මේක වටේ යනවා. මේ අපි මේක වටේ මේක යනවා. So what are the forces exerted on this man පුතේ? මේ මනුස්සයාගේ මේ ඇතුළේ මේ forces මොනවද? Now this is a space colony. This is our earth. Now this is the space colony. Now this one is rotating about this circular path. What are the forces exerted on this man? Very, very important question. මේක මාරම important question එකක්. මොකද මේ මිනිස්සෙක් මේ ස්පේස් කොලොනි එකේ ඉන්නේ. මෙයාගේ forces ටික මාක් කරගන්නවා. Forces ටික මාක් කරගන්න දැන් නැතුනොත් එimhe මේ ගාන හදන්න බෑ. So what are the forces exerted on this man? And with the directions. Harry, direction again. Shashwin, what are the direction? R and MG. What are the direction? Very, very interesting part. So, MG, direction of MG. That is wrong. Actually, there should not be any weight put there, weight, gravitational force, because this is not in gravitational field. This is in the earth. This is in the space. No, put it. This is in the space. Therefore, there is no gravitational fields exerted on this object. Therefore, there is no any gravitational force exerted on this object. Definitely, there is no mass, no weight here, no weight here. But remember one thing. And now in this question, this man is in the space. As this man is in the space, it is beyond the gravitational field. And but you have to remember this thing. Suppose now this man is in the gravitational field. Suppose now this man is in the gravitational field. And suppose this man is not in the earth, but he is rotating a circular path like this, and he is in the gravitational field of the earth. Now definitely there should be two forces. One is the contact reaction, other one is the mg. Weight. What is the direction of weight? What is the direction of weight? What is the direction of the weight? Okay. What is the meaning of weight? What is the meaning of weight? Weight means that is the gravity. Suppose there are two or masses. Suppose there are two masses. So actually we will learn this thing in gravitational field. So due to a mass, there is a force field around this mass. Around this mass, there is a force field. And around this mass, there is also force field. So, due to the gravitational field, normally the force field created by a mass is called a gravitational field. The force field created by a mass is called a gravitational field. So, the force exerted due to gravitational field is called, normally we call a weight. Actually, due to the gravitational attraction, if you are given this kind of two masses in a gravitational field, there are the gravitational attraction force in between them. Gravitational attraction force in between them both. So, gravitational attraction force always exerted on each object from its center to center. So this is the direction of gravitational attraction force. And now this is a small object. Suppose now this object is on the larger object. It is something like we are on the earth. And now this is the bigger mass. Now here is small mass. Now, how to mark the gravitational force, Pute? How to mark the gravitational force? It should be center to center, center to center. So, from here to from here. The top, actually, these forces obeys Newton's third law. Newton's third law of the equal and opposite forces. Those are reaction forces. But they are not in contact. They are not in contact. මතක තියාගන්න reaction forces ඇති වෙන්න contact වෙන්න ඕනේ නැහැ. That is not needed. Reaction forces ඇති වෙන්න contact වෙන්නම ඕනේ නැහැ. අපි කතා කරා එක. මොකද field අපි කියවනේ forces වර්ග දෙකක් තියෙනවා. There are two forces. There are two main forces. One is contact forces, other one is field forces. So if it is a contact force, then the contact reaction is occurred due to a contact. If it is a field force, like this, actually contact reactions can be occurred at a somewhat distance between them. Actually, contact reaction, there are some distance between them. That can be. ඒ නිසා field force එකක් ආවොත් පුතේ contact reaction එකට contact මේ reaction එකක් කියන contact එකක් තියෙන්න ඕනේ. එතකොට මේක contact reaction කියන්නේ නිකම්ම reactions. Therefore, reaction forces can be occurred due to contact as well as there may be reaction forces without any contact. They are field forces. They are called field forces. Okay. Take additional information. Okay? So now those are the forces. Those are the gravitational forces exerted on each object. That is the reason. So sorry. Now suppose now this object, now this man is on this location. Now again, gravitational forces are exerted on center to center. From center to center, therefore forces are exerted on center to center like this. That is the reason we sense our weight is always into the downward direction. Because this is our downward direction. This is our downward direction. If we stay on here, our downward direction is here. Because this is from the earth, this is the surface of the earth. So this is the sky, therefore this one is the downward direction. Therefore, we feel the weight, our weight is always into the downward direction. Because these two forces exerted from one center to other center. That is the reason. Remember, the weight of gravitational force is always from one center to one center. From one center to one center. And one center to one center. ඒ නිසා අපිට මෙතන downward කියන එක තේරුම් ගන්න ඕනේ. So what is the meaning of downward? Vertically downward. What is the meaning of vertical downward? I have mentioned that Timpute. What is the definition of verticality? What is the definition of verticality? It is parallel to gravitational field. It is parallel to gravitational field. Verticality means parallel to gravitational field. So, if we consider about this large mass, its gravitational field like this. Gravitational field like this. Gravitational field. Therefore, if we consider about this kind of location, the vertical is like this. This is the vertical direction. If we consider about this kind of direction, this is the vertical direction. Therefore, vertical direction means parallel direction to the gravitational field. Therefore, vertical downward means it is parallel to the gravitational field and towards the center of the earth. Therefore, gravitational forces are exerted from one center to one center. Okay. And one center to one center. Therefore, don't mark the weight of this man in this direction. That is entirely wrong. That is entirely wrong because the earth is here. The earth is here. Therefore, the gravitational attraction should be from center to center. From center to center. Therefore, in this case, if this man is in a gravitational field, if this man is in gravitational fields, definitely the weight should be in this direction. Should be in this direction. From center to center. Because now here's the earth. Okay, this is the earth. This is the man. Therefore, the weight means the gravitational force should be in between them. In between them. Therefore, don't mark it is in down. මේක අපි හිතුවට මේක downward කියලා මේක නෙවෙයි downward. පුතේ downward තමයි මේ. හරිද? ඒක තමයි downward direction. ඒක මම කිව්වේ හොඳට ඔළුවෙන් තේරුම් ගන්න මේ කියන දේ. හරිද? අපිට vertical කියලා කියන්නේ gravitational field එකට parallel direction එකක් තමයි අපි vertical කියලා කියන්නේ. Gravitational field එකට perpendicular direction එක තමයි අපි කියන්නේ horizontal කියලා. හරි? ඒ නිසා හැම වෙලෙම හිතන්න එපා vertical කියලා කියන්නේ මෙහෙම, horizontal කියන්නේ මෙහෙම කියලා හිතන්න එපා. ඒක වැරදි. ඒ තනිකරම වැරදි concept එක. හරි? ඒක අනිවාර්ය location එකේ location එකට vertical horizontal වෙනස් වෙනවා. හරිද? දැන් එතකොට හිතන්නකො මෙතන දැන් මෙන්න මෙතන ඉන්න මේ මේක earth එක කියලා දැන් earth එකේ මෙතන ඉන්න dial එකක් ඉන්නවා නම් ඒ dial එකට vertical එක තමයි horizontal එක තමයි. දැන් මෙයාට vertical තමයි මේකේ. මෙයාගේ horizontal වෙන්නේ මේ පැත්ත. දැන් මෙයාගේ vertical වෙන්නේ මේ පැත්ත. horizontal වෙන්නේ මේ පැත්ත. ඒක නිසා location එකෙන් location එකේ තියෙන vertical horizontal වෙනස් වෙනවා. අපිට ඉතින් හැම වෙලෙම මෙතන කොහෙන් ආවත් පුතේ මෙතන ඉන්න එකාට උඩ බැලුවම පේන්නේ අහස. මෙතන ඉන්න එකාට උඩ බැලුවම පේන්නේ අහස. මෙතන එකාට උඩ බැලුවම පේන්නේ අහසනේ. ඒක නිසා අපි හිතනවා අහස පැත්ත තමයි vertical කියලා. අහස ලැබෙලා නම් අන්න ඒක vertical කියලා අපි හිතන්නේ. හරි that is wrong. ඒක නිසා අහස දිහාට vertical කියලා හිතන්නේ එපා. Vertical means perpendicular, so parallel to the gravitational field. Therefore, if this man is in a gravitational field, and if this is the earth, definitely the weight of this man should be directed towards the earth. Is that clear? If it is clear, please raise the hand. පැහැදිලි නැත්නම් හරිද ශාස්ත්‍රඥ හරිද is that clear? You have wrote down that thing, and so in this case there is no way put it because according to this question, this man is in space. Space means that is far away from our gravitational field. Normally, space, the word space represent a location where there is no any gravitational field. Okay, that's why we call it as space. Space gravitational field like therefore there is no any gravitational force. But if there's a gravitational force, definitely it should be into the earth, into the direction of earth center. If you want to write anything now, you are free to write. So this is the force diagram. This is the force diagram relevant to this question. This force diagram is relevant to a Man who's in a gravitational field, but somewhat about the earth. Okay, now we can mark the forces exerted on this man. Now we can mark the forces exerted on this man. Actually, this question is very easy question. This question is very easy question. The only consideration is you have to identify what are the forces and what are the direction of those forces. So if you cannot identify that thing, or if you cannot determine that thing, then you cannot do this question. That is the problem. That is the problem. If you mark mg, then you cannot do this question. And here there's no mg. Here there's no weight put it. Here there's no weight. There will be contact reaction. There will be contact reaction due to a contact between the space shuttle and the man. Space shuttle and the man. Therefore, this contact reaction is directed towards the earth, towards the center, towards the center. Therefore, this man exerted on this. This man exerted this. This man's field. So this actually there's only force. So this is the only force exerted on this man. This is the only force exerted on this man, and that force will provide the centripetal force. Therefore, if we apply F equal ma to this direction, R should be equal mr omega square. And you are asked to determine omega so that this contact reaction should be equal to the weight, at the earth, weight on the earth. So if it is equal to the weight on the earth, it should be equal to mg. Therefore, if this one is mg, what would be the omega? That is what. Ampere will be cancelled out. This one is 10. This one is 10 to the power 3. 10. This one is 10. This is 10 to the power 3. 10 here, 10 to the power 3 here, 10 to 10 to the power 3, 1 will be cancelled out. Therefore, 10 to the power minus 2 is equal omega square. Therefore, omega should be 0.1. Yes. Therefore, answer number 1. Therefore, if you can mark the forces, within your mind, then actually there's no question here. There's no question here. Whether a question like that, forces to mark forces to mark no? Question. Is that clear? If it is clear, please raise the hand. Give the I need responses from everyone. Hello, that's it. Submit. Thank you. Okay. You can write this review part, okay? Write this review. As this man in his space, there's no gravitational force exerted on the man. There's no gravitational force exerted on the man. Therefore, the only force, the only force exerted on the man is the contact reaction. Therefore, the only force exerted on this man is the contact reaction. They write in as a special note. Write this as a special note. Suppose if this man is in a gravitational field, suppose suppose this man is in the gravitational field of the earth. Suppose this man is in the gravitational field of the earth. Suppose this man is in the gravitational field of the earth. A gravitational force, a gravitational force is occurred from one mass to the other mass. From one mass to the other mass. Therefore, in such cases, therefore, in such cases, therefore, in such cases, the weight, the weight, therefore, in such cases, the weight should be directed, should be directed towards the center of the earth, towards the center of the earth. Towards the center of the earth. You can mark it, okay? You can mark it. Therefore, this is the gravitation. This is mg. මම නිකන් ක්වෙස්චන් එකක් අහලා. හරි. පාඩල හිතුනොත් කියලා. මෙන්න එර්ත් එකට පුතේ මේ mg කියලා ෆෝස් එකක් එනවනේ. එතකොට එර්ත් එකට එන mg ෆෝස් එකෙන් එර්ත් එකට කියන්නේ මේ එෆෙක්ට් එකක් වෙන්නේ නැද්ද? එර්ත් එකට එෆෙක්ට් එකක් වෙන්නේ නැද්ද? එර්ත් එකයි මේ මොබිලයිස් වෙන්නේ. ඒ කියන්නේ මූව් වෙන්න බෑ. ඉතින් එක්ස්ටර්නල් ෆෝස් නිව්ටන්ස් ෆර්ස්ට් ලෝ ගන්නවා එක්ස්ටර්නල් ෆෝස් එකක් ආවොත් ඉතින් මේක මූව් වෙන්නේ. දැන් එක්ස්ටර්නල් ෆෝස් එකක් තියෙනවා. මූව් වෙන්නේ නැද්ද? ටිකක් ලොකු ෆෝස් එකක් හිතමු. හ්ම් මොකද කියන්නේ? නැහැ වෙයි. No, it cannot be happened with it. So what is the reason? Pute, those two forces are internal forces with respect to the gravitational fields because actually Earth is a mass. Actually, mass, if there's a mass, it has a gravitational field. It has a gravitational field around this mass. Okay. So if you want to move this man, definitely you have to apply a force to. And so, if there is a force inside this gravitational field, it is a internal force. It is internal force because this is the mass. Although this is the mass, this is its gravitational field. Therefore, if you consider about this gravitational field, all the forces are inside. Therefore, those are some internal forces. Therefore, although there is a force exerted on this Earth, due to its mass, Earth will not change the moment. And the Earth will not change the moment because it is inside the gravitational field. So if you can affect the Earth from outside, then we can change the direction, but it cannot be happen due to this kind of forces. එතකොට එළියෙන් මොකක් හරි ෆෝස් එකක් ආව දැන් අපි සන් එක තියෙන ෆෝස් එක බලන්න සන් එකයි එර්ත් එක අතර තියෙන ෆෝස් එක එක්ස්ටර්නල් ෆෝස් එකක්. ඒක නිසා තමයි මේ එර්ත් එක අපි මේ සර්කියුලර් මොෂන් එකේ යන්නේ. හරි. ඒක නිසා තමයි සර්කියුලර් මොෂන් එකේ යන්නේ. Okay. Okay, now do the question number 40. Now do the question number 40 quickly. If the Earth rotates with a different angular velocity for an object placed on a point of the Earth equator, the velocity that should possessed by the point to make the apparent weight zero. Apparent weight zero. Apparent weight. What is the meaning of by apparent? What is the meaning by apparent weight? What is the meaning of apparent weight? Apparent weight can apparent weight. Okay, Bhute. What is the meaning of apparent weight? Apparent weight take again. Look at this. Now, this is a balance. There's a balance. Now this is spring balance. Sorry, weight press. Now here an object. This is an object. So what is the meaning of the weight? What is the meaning of apparent weight? What is the meaning of apparent weight? Apparent weight means, look at this one. If we mark the forces, there's a weight of the object. And in between this plate and this mass, there's a contact reaction into the upward direction. And according to Newton's third law, there will be a equal and opposite force on this plate. So due to this push, what will happen? This balance will be pushed into the downward direction due to this force. And so by this contact reaction in between these two objects, or that means object and the balance, due to the contact reaction in between the object and the balance, there will be a push. Push means there will be a force on the balance. Due to this push, its scale will show a reading. Weight value. Will show a reading. So you know, according to the equilibrium of this object, definitely R should be equal W. Therefore, you can observe the reading of this balance is W. Actually, reading of this balance is W. Actually, this reading should be equal. Actually, this reading is due to this push. Therefore, this reading is R. And R is equal to W. This reading is R, but R is equal to W. Therefore, this is called apparent weight. Apparent weight means definitely it is a contact reaction. That is the meaning of apparent weight. Contact reaction. Therefore, the apparent weight should be equal to contact reaction. Contact reaction may be a perpendicular reaction like this, or it may be a tension force. Tension force where is a contact force put it, that also contact force. Therefore, an apparent weight should be a contact reaction or contact force. And so if it is a spin balance, it will be the tension force. Okay. Is that clear? If it is clear, please raise the hand. Clear, sir? So contact reaction means R. So now contact reaction should be 0. Right? Alright. Now there is a man here. On the earth. Now this is the suppose this is the equator. Now there is a man on the earth. So as we discussed earlier, definitely mg should be into this direction, into the center. Now there is a contact reaction into this side. Contact reaction into this side. So according to this question, the apparent weight should be equal to 0. The apparent weight means the contact reaction. Therefore, here the contact reaction should be 0 because apparent weight is 0. Therefore, now there is only one force, that is mg. Now there is only one force, that is mg. So if we apply equilibrium to this side, the force is mg is equal to the velocity. You ask the velocity, not the angular velocity. Velocity, therefore, I can write mv squared over mv squared over. Therefore, m can cancel now. V squared is equal rg. Now radius is equal to radius of the earth, that is 6.4 into 10 to the power 6. 6.4 into 10 to the power 6. 6.4 into 10 to the power 6 into 10 means 64 into 10 to the power 6 today. That means V is equal 8 into 10 to the power 3. M minus 1. Not the weight, Pute, the apparent weight. The apparent weight. Not the weight. The apparent weight can be changed. Weight means mg. Weight means mg. Mg means that is the attraction force between the earth and the object. The attraction force between the way between the earth and the object. Actually, that depends on the distance. If you increase the distance between the earth and the object, then the attraction force decreases. That means the weight decreases. Therefore, if you increase the distance between the object and the earth, if you increase the distance between the object and the earth, then the weight of the object decreases depending on the distance, from the earth center to the object. Earth center in the object in the distance එක අනුව එයාගේ weight එක අඩු වෙලා there will be a place where the gravitational field will be 0. And we call it as infinity with respect to the gravitational field. Gravitational field with respect to the infinity. Location if we consider about a certain location, gravitational field is a constant. If we consider about a certain location, gravitational field is a constant, but R can be changed. R can be changed due to the external accelerations. How do you think? Is that clear? Okay, you can note down this thing. හොඳට මතක තියාගන්න මොකක් හරි එක ලොකේෂන් එකක් ගත්තොත් mg වෙනස් වෙන්නේ නැහැ. mg වෙනස් වෙනවා නම් ලොකේෂන් එක වෙනස් කරන්න ඕනේ පුතේ. ඒ නිසා ඒක තමයි නම්බර් 1. එක mg එක ලොකේෂන් එකට mg ඕනේ. හැබැයි r වෙනස් වෙන්න පුළුවන්. අපි මෙයාට දෙන accelerations ඊට පස්සේ decelerations අනුව. Hello. Shall I erase? Then question number 70. Look at the question number 70. Question number 70, 2030. Question number 20 is 2013 question. Now there's a spin like this. There's a mass. And there's another spin like this. And these two ends are fixed. These two ends are fixed. Actually, this is something of this. Now P, M, Q. Here P, M, Q. Now, this is the question. One end, each of two identical stretch springs are fixed to the two ends of a closed tube, and the other ends of the springs are attached to a mass, simple end, as shown in the figure. Which of the following motions of the system result in a displacement of a mass m towards P from the center of the tube? That means due to one of these motions put A, this mass will move towards this direction. This mass will move towards this direction. So if this mass will move towards this direction, what will happen? What will happen? What will happen? This spring will stretch more than this spring. Okay? Because now this spring will contract about this spring will contract, and this one will be stretched more. Okay? Therefore, the elongation of this side will be higher than the elongation of this side. Therefore, elongation of this side is higher than the elongation of this side. So, due to this reason, the tension force exerted on this side should be higher than the tension force exerted on this side. Therefore, if this is occurred, what will happen? Tension force on this side is higher than the tension force of this side. That means there will be an unbalanced force on this object on this simple math is in this direction. Definitely there will be an unbalanced force into Q side, Q side. There will be unbalanced force into Q side. That is the point with it. And අපි බලමු ඉතින් මේ පැත්තට unbalanced force එකක් එනවා මොකද වෙන්නේ? First one. Uniform acceleration of the tube in the direction of PQ. What will happen? This is the first motion is if we move this tube, in this direction, what will happen? If we move this direction, if we move this tube in this direction with a uniform acceleration, what will happen? Definitely, this object should have that acceleration. As this object has that acceleration, definitely this object should have an unbalanced force into PQ direction. This object should have an unbalanced force into PQ direction. To create an unbalanced force, definitely this object should move in peak direction, because if this object moves in p direction, definitely the situation like this, there will be unbalanced force into this direction. Therefore, if this tube moves in this direction, definitely this will go backward. බස් එකක ඉන්නවා වගේනේ. බස් එකක ඉන්නකොට නිකන් අපි ඉස්සරහට ඇක්සලරේට් කරනවා අපි යන පස්සට. හරි. ඒ ගාන ඇක්ලේ මෙයා ඉස්සරහට ඇක්සලරේට් කරපු ගමන් පස්සට යන්නේ. ඒකයි මේක දෙකක්. පස්සට යන්නේ ඇයි? පස්සට ගියම මේ පැත්තේ ටෙන්ෂන් එක වැඩි වෙනවා මේ පැත්තේ ටෙන්ෂන් එක අඩු වෙනවා. මේ පැත්තේ ටෙන්ෂන් එක වැඩි වෙනවා මේ පැත්තේ ටෙන්ෂන් එක අඩු වෙනවා. එතකොට අන්බැලන්ස් ෆෝර්ස් එකක් වෙනවා මේක. එතකොට මේ අන්බැලන්ස් ෆෝර්ස් එක නිසා මේ acceleration එක මෙයාට ගන්න පුළුවන්. Then acceleration again, there should be an unbalanced force into that direction. Therefore, the statement number A should be correct if there's a uniform acceleration. If there's a uniform acceleration towards the right hand side, definitely this will move into left hand side. Is that clear? If it is clear, please raise that there also. Okay. Therefore, statement number A is correct. Statement number A is correct. How do you do it? Statement number A is again. May I uniform acceleration again? Put the uniform acceleration in uniform acceleration in definitely this object should move into the direction of P. This object should move into the direction of P. If this object moves into the direction of P, the elongation length of this string will be higher than this distance, Therefore, tension force of this side is higher than the tension force of this side. That means there's an unbalanced force in this direction. This unbalanced force provides this acceleration. Then, if this object moves in left hand side, MQ is spin. Will be stretched will be stretched more than the MQ spring will be stretched more than MP spring. MP spring. Therefore, the tension force in MQ side, therefore tension force in MQ side. Therefore, the tension force in MQ side should be higher than the tension force of MP side. The tension force of MQ side should be higher than the tension force of NP side. Therefore, definitely there is an unbalanced force. Therefore, definitely there is an unbalanced force towards MQ. Therefore, definitely there is an unbalanced force towards MQ. Therefore, we should determine a motion. Therefore, we should determine a motion Therefore, we should determine a motion that requires an unbalanced force. That requires an unbalanced force towards MQ. Towards MQ. Hi. That means step number A is correct because if there's a motion into this side, if there's a uniform acceleration, if there's a uniform acceleration towards this side, that means definitely there should be a force in this side. Therefore, definitely there should be a instant like this. Rotation of the tube around a vertical axis passing through Q. Yes. Now this is the center. Now this is a point where on the circumference put it. Therefore, definitely, if there's a rotation, if there's a rotation about Q, definitely there should be an unbalanced force in this side. That means definitely to provide the unbalanced force, this object should move in backward direction. And therefore, answer number B should be correct. Answer number B should be correct because if there is a rotation, if there's a rotation about this, definitely there should be a centripetal force exerted on this object into this direction. Into this direction. And therefore, definitely the question number, answer number B also correct. C. Vertical motion of the tube under gravity keeping Q below P. Keeping Q below P පුතේ ඒක වෙන්නේ නැහැ. ඒක වෙන්නේ දෙයක් නැහැ නේ කණිත් පැත්තමත් වෙනවා පොඩ්ඩක් හරි ගන්නකොට Q below P කිව්වොත් Q වෙන පළහැදී. එතකොට Q ගේ පැත්තට යනවා. යනවා. එහෙම යන්නේ නැහැ රේට් එකක් නේ. Therefore, statement number C is a incorrect statement. Incorrect statement. Therefore, answer is A and B only. A, B only are there are two answers. There are two answers either. Answer number 2 or 4. 2 in the pool or 4 in the pool. Is that clear? Wait, you know, sir. පැහැදිලි නම් තුස්ස. ඕවනේ අද කටවතියි. Okay. Okay, good. Then we can complete today's class with it because today is our extra day. As I couldn't able to do the class yesterday. Actually, I have planned to do an additional class on today with it. So this is that additional class there. But the thing is, most of the students cannot participate for this class because they are on schedules. So I will share the recording as immediate as possible. Then please watch the recording. Everyone, please watch the recording. Then the next paper class will be held on Wednesday from 7:30 to 10:30. 7:30 to 10:30. Okay. So that is our normal time schedule. Then there will be a full day class from 7 a.m. to 10:30 p.m. On wave lesson on next Tuesday. On next Tuesday. So as I mentioned earlier, the first session will be waves. The second session we will start light. Okay. Hi. So we can conclude today's class with it. Everyone, good night. Everyone.